Hello everyone. So today we're gonna be doing day one of Advent of Code in Python. So for those of you who don't know what Advent of Code is, I only found out about this 3 weeks ago. But basically, it's like a coding competition that goes from the 1st of December to the 25th of December, and every day they release two problems. And if you're the first 100 in the world to solve it, you get some points, and there's like a world ranking. Uh, I don't really like this system because it's just the people who solve it in the first 100 people who solve it just do it at a ridiculous speed. Like, I don't know how they type so fast. But anyhow, so the day one problem is basically, it's got this little cool little Christmas story, but basically it gives you two sort of lists, as you can see vertically, like this is a list and this is a list. So we want to pair up the smallest number in the left list with the smallest number in the right list, and so on and so forth. And then it wants you to figure out how far apart those corresponding pairs are. So, for example, the smallest one here is 1, smallest one here is 3, so the distance will be 2. And then once you find the distance of all the pairs across the two lists, then you want to add them all up together into a total, and that's the answer. So basically, for this question, to do it in Python, it's in the word, right? So we need to create two lists. So we have list one equals to an empty list, and list two equals to an empty list. So now we want to read in the input. So I put the input.txt in this file here. And in Python, it's pretty convenient to read something. So you can open the input.txt. So this just opens it in read mode as F, and then you can do for line in F. So it just reads it in line by line, and it's going to. And then what you can do is, as you can see, it's separated by some white space, right? So you just do line.split. That was separated by white space, and I believe you get two parts to it. So you get part A and part B. We can unpack it using this very nice Python syntax trigger, and then we just do list one dot append A and list two dot append B, and then we just print. Let's just print the first, the first 10 elements of the both lists, just to check that we're not losing our minds. Okay, so let's give this a run. Oh, why am I? So let's go to cd advent of code, and then cd day 1 Python 1, and so we get 39472 417 795, blah 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 blah, and this blah 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 blah. So clearly we're passing this file correctly. Yeah, Python is just super nice in terms of handling I/O, just because like there's so much syntax sugar and wrapper code that you don't really need to do that much work yourself. Anyhow, and then we just do list one. So now we want to pair up the smallest from list one and the smallest from list two, and the second smallest from list one, and the second smallest from list two, right? So I guess the key idea here is we don't really need to search through both lists. So you don't have to search through the smallest to find the smallest one in the first one, and then find the smallest one in the second one, and then find the second smallest one in the first one. So on and so forth. It's very time consuming. So what you can do is you just sort the two lists, right? So because once the two lists are sorted, then they uh, they the numbers at the same index in both lists, they have to correspond. So you have, because the smallest number in the first list will always be index 0, and the smallest number in the second list is always index 0, and so on and so forth. So we'll just do this one dot sort. So in Python, you can see sort returns none. So this sort function is actually a side effect. It just mutates the list in place. In other words, it doesn't create a new list. It just sorts the existing list, and your original data in the list is destroyed. So, so that's a little. It's pretty important. It's something to be careful of. And then what we can do is we can loop over the two lists. Because we have to loop over two lists, using a for in loop is probably a little bit harder than if you just use an index-based looping. So we can do so for I range length of this one, and then we can we can get a equals to list one I, right? So obviously range goes from 0 to whatever the length of list 1 is, and then we can access the items from list 1 and list 2, and then we can get the distance equals to a minus b, and hopefully for the keen-eyed of you, you would have noticed that something is wrong in this code. And then we can just put some. Right, so if you're not too sure, feel free to pause the video. Yeah, so when we find the distance, sometimes A might be bigger than B, but sometimes B might be bigger than A, right? So the distance has to be an absolute value. So, and then we want to do sum plus equals the distance. Okay, now we run this code. Okay, there was something else that's also wrong in the code. Is we have to convert it to an integer, right? Int, also int, and then give this a run, and we get 765,748. So, hold on, let me just log in. So yeah, got the input, and then now we put in this value, and as you can see, we get gold star, hooray! And then part 2. So in part 2, it's it's quite different actually. This problem is you can't really reuse too much of the code from part 1. So let's go to part 2. Yeah, this is what I had already. So obviously we can reuse the code for passing in the input, since the input is always the same across the two parts of the problem. And then here we open the import, and then we have we put it into two lists. And then if we read the question, basically for every number in the left list, we have to multiply by how many times it appears in the right list. So for example, 3 is here, right? And 3 also appears 3 times here, so we got to do 3 times 3. 4 is here, and 4 also appears 1 time on this list, so it's 4 times 1. So hopefully it's obvious that here we really want to loop over the first list, and then try to find the element of the first list in the second list, right? So let's just do the naive approach first. So we literally just for num in list 1, yeah, and then for num in list 1, we we also want to loop over the second list for num2 in list 2. And so the number of times it appears for each number, it starts off at 0, right? Appear equals 0. And then, so, but if the two numbers are the same, 1 equals, for num equals num2, then we want to increment appear. And then finally, so for each number in the first list, we loop over the whole second list, and then we count how many times that number appeared in the second list. So then now finally we just calculate the similarity score. So the total equals 0. Sim equals to appear multiplied by the original number. Total plus equals sim, and then prints total. Oh yeah, that's right. Make the same mistake twice. Wonderful. So here we need to convert it to an integer. I think in Python it's not too big of a deal if you leave it as a string until you convert it here. Otherwise, something you can do is like you can actually do something like this where you can map ints onto this, and then you convert it back to a list. So this looks really fancy, and it's a functional pattern, but it's not too complicated. Basically, what it does is list split. Line.split is a list, right? So when we do map, we can run this int function on every element of this list. So every element of this list has the function line applied to it. So has the function int applied to it. So all the strings are converted to ints, and then we just convert it back to a list again, because this returns a map type. Honestly, I don't a map object. Honestly, I don't really know much about the map object in Python, but yeah. So this way we get the int. So either of these approaches will work, and then run it again. We get 225, 39, 317. Okay, wonderful. So we put it back in, and we got another gold star. Fantastic. So this approach is it's okay, but if we do a complexity analysis, we'll realize that this is actually a like n squared solution, right? So if n is the number of lines given to us in the input, so in this particular case n is 6, then for each number on the left we have to do 6 times, right? So for 3 we have to loop over the whole second list. For 4 we have to loop over the whole second list. For 2 we have to loop over the whole second list, so on and so forth. So we end up with 36 executions, and it's a n squared algorithm. So it's not the most efficient, it's not terrible, but what we can do is we can actually create a simple count of how many times all the numbers appear in the second list. So we can actually just loop over the second list. So for num2 in list 2, loop over the second list, and we can create a dictionary. Count equals to a dictionary, and basically we just count how many times any number appear in the second list. So for example, we count that 3 appears 3 times, and 4 appears once, and 5 appears once, and so on. So the number is the key, and how many times it appears is the value. So we can do something like counts dot get num2. If num2 doesn't exist in the dictionary yet, we just give it a default value of 0, right? So we'll just do +1. So basically, if it doesn't exist yet, we assign it the value of 0 and then we +1. Otherwise, we get what the current value is and then +1. Right, so this way we're incrementing how many times we count a particular number appears, and then we just do count num2 equals to this. So then this way we end up with a dictionary of every number in the second list, how many times it appears. And then so when we loop over the first loop, we can simply access this value, right? Appear equals to counts num, and then we just do sim equals to appear multiplied by num, and and then we still have the total equals 0 and 1 num. Oh, something's not right. Also, I probably can't do this because if a number appears in the first list and not the second list, then this would return a key error. So probably this will be much better. Did I already? What's wrong with this code? Oh, I did this too again. Stupid. This one. Yep, and then we end up with the same value. So if we do a complexity analysis on this, like I guess theoretically the worst case for a dictionary to get is actually like ON, because it might be all clashes, but the expected complexity of a dictionary is O1, right? So as you can see, we just loop over the second list once, and we loop over the first list once, and that's just 2 times n. So it's not a nested for loop, as you can see here. So that's just a ON solution, which is much more efficient. But of course, it doesn't really matter for a competition like Advent of Code. A lot of the time, even if you just brute force it, it just you just get the like it doesn't matter, like you're only running it once anyway, and modern hardware is so good that it's probably gonna give you the answer in like 2 seconds. So anyway, that's the day 1 Advent of Code. I'll also do the other days as well, and then I'll see you in the next video.